Okay, so in this video, I'm going to discuss example 4. Okay, so this example 4, given 3-point charges here along the x-axis. So we have Q1, Q2, and Q3, and given the distance between Q1 and Q2, which is 12 centimeter, Q2 and Q3 is 20 centimeter. So question A, calculate the magnitude and direction of the total electrostatic force exerted on Q1. So we want to find the total force on Q1. So first of all, we will sketch the direction of the force. Okay, so Q1 and Q2, positive dan negative, they akan attract. So meaning that there will be force going towards Q2, which is F21. Sebab dia satu positif, satu negatif. And now, Q1 and Q3, satu positive dan the other one is also positive. So they will repel each other. So there will be a force F31. Now kita kena cari satu-satu untuk cari the total. Cari satu-satu dahulu. So we do the F21 first using Coulomb's law. Q1, Q2 divided by I12 square. So K is the constant and Q1 is 12 microcoulomb, Q2 is 20 microcoulomb divided by the distance between 1 and 2, which is 12 centimeter, convert to meter, and then you will get 150 Newton. And this one is going to the right. Next one is F31, still using Coulomb's law. Q1, Q3 divided by the distance 13 square. Again, K is constant. And then Q1, 12 exponent negative 6. Q3 is 36 exponent negative 6 divided by the distance between Q1 and Q3. So distance dekat sini adalah from here to here. So 12 tambah 20 will be 32 centimeter. So convert to meter then square. And then you will get 37.97 Newton. And this one, F3 here is going to the left. So it will be negative and then to the left. Now that we have F21 and F31, we can find the total electrostatic force. Which is equal to F21 plus F31. F21 dekat sini adalah positive 150 and then tambah dengan F31 which is negative 37.97. So the total net force here will be equal to 112 Newton. And since it is positive, so meaning that the direction will be to the right. So now let's look at second question. Question B. Suppose the charge Q2 can be moved left or right along the connecting line. So determine the distance from Q3 where Q2 experience electrostatic force of 0. So dia bagi tahu dekat sini, this Q2 we can move to the right or left. So now apabila kita alihkan kedudukan Q2 ni, kita mau tahu di manakah kedudukan dia apabila Q2 mengalami force sama dengan 0. Let me redraw that first. So now that I redraw the diagram, what we want is Q2 dekat sini akan mengalami total force sama dengan kosong. Dan soalan minta distance from Q3 di mana Q2 sama dengan kosong. So maksudnya distance daripada Q2 kepada Q3. So we want to find this distance here, which is we just put it as X lah. But the distance daripada Q1 total distance daripada Q1 ke Q3 masih lagi sama, which is 32 cm. Okay, so meaning that distance from here to here will be 32 minus X. And since the distance, since the total force here will be equal to 0. So kita lukis dahulu apa force yang terlibat di sini. Okay, so negative and positive akan attract each other. So we'll have F32, and then positive and negative juga akan attract each other, and we have F12. So from here we can say that F12 plus F32 will be equal to 0. So dia bagi tahu total force adalah sama dengan kosong. So meaning that F12, okay, the modulus of F12 will be equal to the modulus of F32. Okay, sepatutnya dia adalah negative, but now we just put modulus, so we just assume the magnitude only. Okay, using the Coulomb's law, so K Q1 Q2 divided by R12 square equal to K Q3 Q2 divided by R13 square. So dekat sini kita boleh padam, cancel K and K, then Q2 and Q2. And this one is actually, okay, 32 minus X, and this one is actually X. So kita masukkan value dia. Q1 adalah sama dengan 12 eksponen negatif 6 divided by, okay, this one kita ubah terus kepada meter lah. So 0.32 minus X and then square equal to Q3, which is 36 exponent negative 6 divided by X square. Okay, so from here I don't need to show you the mathematics. Okay, so final answer you should get, okay, you should get 0.203 meter. Okay, that is all for example 4.